In the first lesson of this module, we're going to be looking at how we can fade the volume of an audio source as it is played. We're going to be going back to our music script and see if we can get it to fade in as our game begins. We'll also be looking at a few new concepts today, such as coroutines and the time.deltaTime property. Now, these can be a little bit confusing and hard to understand, especially the deeper you dive into them. So we'll try and keep things nice and easy to understand and focus mostly on how to use them in our scripts for fading music. Let's get the hard one out of the way first. Now, a coroutine is a special type of function. As we know, when a normal function is called, it completes all of the instructions it was given within the frame that it was called on, almost instantly. However, a coroutine doesn't necessarily have to complete its tasks straight away. Instead, we can use them to spread completion of any instructions given to it over multiple frames, or even over a period of time. Unity defines a coroutine as a function that is executed in intervals. I like to think of them as functions that we can pause and then resume again. Because of this, they become extremely helpful whenever we want to work with time in our game. For example, creating timers or pausing certain parts of our game. Now let's take a look at how we might use a coroutine in one of our scripts. To declare a coroutine function, we start by writing IEnumerator as the return type. Now don't worry too much about what this big scary word means. It's really not necessary for us to know. It just means that we can only return specific things, which we'll look at shortly. We then give the function a name, 2 parameter brackets in case we wish to use parameters with the function, and a body, just like any other function. Then to call the function to run, we actually have to use another function called start coroutine. We then write the name of our coroutine inside the parameter brackets of the start coroutine function, as well as its own pair of parameter brackets. So declaring and calling a coroutine is simple enough. Now let's take a look at what makes these things so special. Let's say we wanted to send 2 messages into our console tab in Unity. The first as soon as the game starts, but the second we want to appear 3 seconds after the first. Well, thanks to this coroutine, we can do just that. First, we'd use the debug.log function to display our first message. So we'd write that inside of our function. Next, we would write this new line of code. Yield, return, new, wait for seconds, and give it the number 3, the amount of seconds we wish to wait for. After that, we then give it the second message by again using the debug.log function. So now, when our game starts, our coroutine function will be called and our first message would be displayed, all within the length of time it takes to render a single frame. Then our function would read its second instruction and pause itself for the amount of time we told it to, which was 3 seconds. Finally, once the 3 seconds are up, it resumes execution of its instructions and displays the final message in the console tab for us. Now let's break down that line of code that actually told our function to wait to understand it a little bit better. Now the first word we see is yield. Yield is a special keyword that only works inside of these coroutines that have been declared with the IEnumerator type. Now, like I mentioned at the beginning, we're not going to go too deep into understanding how some of this works, including this new keyword. All you need to know is that by writing yield, you're saying to your function, hey, I'm about to tell you to pause what you're doing for a certain amount of time. If it helps, imagine you're telling your function to yield or give up control and let Unity to continue in the background without it for a while. Next is the keyword return. Now we're already familiar with this keyword and we know that it tells our function to return a value or an instruction out of itself, depending on the return type declared at the beginning of the function. Well, the same idea applies here. Because the return type of the function is IEnumerator, we can only return specific things. Depending on what we return will dictate how long our function will pause for. One thing we can return is a new instance of the wait for seconds class, a class which tells our function to wait for a given length of time. Now you don't have to use the wait for seconds class here. There are others that will change by what measure our function waits. But wait for seconds is a very popular and useful, so it's always a good one to start off with. And like I said, this is a very surface level explanation of what is happening here. here. But that's all we need to worry ourselves with in order to use these effectively, because a lot of this is handled by the back end of Unity's API. Here's a couple of things to remember before we move on. For any of this to work in your script, you'll need to make sure that you have the namespace system.collections at the top of your script. This is included by default whenever you make a new script, so you shouldn't have to add it yourself, but just in case you removed it, you'll find that your script won't recognize things like the IEnumerator return type, so be sure to add it back. Also, whenever we talk about a coroutine pausing or waiting, it's important to understand that we're not pausing our entire script. It's only the coroutine function itself that waits. So if you have any other functions in your script, say the update function for example, they will continue to run as normal whilst your coroutine waits. Okay, so that's all of the basics and essentials we need to know about coroutines. Now it's time to jump back into our game and see how we can use these to tell our music to fade in when our game starts. Okay, so to do this, we'll need to open up our music player script that we created back in the first lesson of Module 2. So let's select our music object, scroll down the Inspector tab to the music player script, then let's open it up and edit it. Okay, so as we know, we want to tell our script to fade our music in over a given period of time. For now, let's say that we want to fade our music from 0 to 1 over a single second. Then later on, we'll look at making the fade time longer or shorter, as well as changing the starting and final volume values. First, we'll need a coroutine in order to handle the volume control of our music as it fades in. We want the fade to begin straight away, so we'll tell it to start on the very first frame so that our music fades in as soon as our player starts the game. So let's remove the update function, as we won't be needing it, and in its place, let's declare a function with the IEnumerator return type. We'll then give this function a name such as fade music in and finish declaring the function. Then inside the start function, we'll start this coroutine. Now we want this to start immediately after we tell our music to play. So underneath the play function, let's call the start coroutine function and let's tell it to trigger the fade music in coroutine. Great, so now our coroutine will start straight away. Okay, so now how are we going to tell our music to fade over time? Well, using the coroutine, we're going to increase the volume of our audio source by a very slight amount every frame until it reaches 1. The amount at which we increase the volume by will obviously depend on how long we want the fade to be. A longer fade means we'll need to increase the volume by a smaller amount each frame, and a shorter fade will need bigger increases. So in order to do this, we're going to need to understand the relationship between frame changes in our game and how Unity tracks time. Now, as we know, our game is made of multiple frames that render and show our game to the player one after the other, multiple times per second. Not only are these frames still images that combine together to create motion, they are also what our script uses to execute functions and instructions. Now, a lot of games today run at about 60 frames per second, depending on the game, the system running the game, and other factors. However, that's not to say that the time between those 60 frames is exactly the same every time. Some frames will take longer to render and appear on our screens than others, depending on what our game is trying to process and show to our player. The more the game has to process, the longer it takes to render and show us these frames. This is why many games start to show less frames per second when a player reaches a part of a game that has to handle and process lots of things at once, such as a large wave of enemies in a shooter, for example. With all of this in mind, let's break down our plan and see how this will affect how we go about coding our fade in coroutine. We want our music to fade from a volume of 0 to 1 over a second, and there are 60 frames in a second. So if we divide 1 second by 60 frames, we get 0.016 reoccurring, the time in seconds it would take each frame to be processed and rendered on screen. Okay, so if we want to increase our music by 1 evenly over those 60 frames, surely we just increase the volume by 0.016 0.00116 each frame? Well, unfortunately not, because remember, the time between frames is not always the same. Whilst the average will be 0.016 seconds, depending on what's happening in the game, some frames may take much longer than this and others much shorter. Let's say, for example, the player was causing a lot of explosions and the frame rate dropped from 60 frames to 10 frames per second. If we told our game to fade the music in by 0.016 of a second per frame, our music would only increase in volume by 0.16 by the end of the second. So instead of increasing the volume by 0.016 each frame, we need to increase it by however long it took each individual frame to render. But how do we find out how long each frame is on our screen for? Well, thankfully, Unity's API provides us with a property that we can check within our script to find out. It's called time.deltaTime. Time.deltaTime is a float that provides us with how much time in seconds has passed since the last frame and the current one. This is going to be very helpful to us for two reasons. First, instead of increasing our volume by a fixed amount, we can increase it by the amount of time it takes each frame to render, thus increasing it at the same rate that time is passing. Second, we can take time.deltaTime and add it to a float variable each frame. By doing this, we're combining the time of each frame, essentially creating a running timer in our script. We can then use this to see how long we've been increasing our volume for, and stop once a second has passed. Okay, great. So now we have a better plan to increase the volume of our music by the length of time it takes each individual frame to render and process per frame. Now let's take a look at how to write that out in C#. Okay, so inside of our script, the first thing we'll need is a float variable. We'll use this variable as a timer and track how long it's been since our coroutine was called. This variable can be a local one, so let's write it inside of our fade music in function. Let's write float, call it timer, and start it at 0. Next, we'll use a while loop to increase our volume by each frame's render time per frame. We'll make sure that this happens only whilst our timer hasn't passed 1 second. So we'll write whilst timer is less than 1. Great. Next, we want to tell the volume of our audio source to increase by the amount of time it has been since the last frame ran. To do that, we'll write the name of our audio source variable dot volume and add whatever length of time time.delta_time is currently holding. Now that we've increased our volume, we now want to update our timer with how long the last frame took before we increase our volume again. Now underneath that line, let's write timer and again add whatever length of time time.delta_time is currently holding. And there we go. So now our volume increases ever so slightly, and so does our timer. Now normally, a while loop will execute its instructions multiple times, all within a single frame, not once each frame, which is what we want it to do here. However, this is where our coroutine comes into play. Inside of our while loop, right at the end of the first loop, we're going to tell our coroutine to pause. And as we know, we do that by writing yield return. Now the idea here is that after each successful loop, we want to tell our coroutine to pause and wait until the current frame rendering has finished. Once it has and a new frame is rendered, it can then resume. Once it resumes, our loop will run for a second time. And because it is now running on a different frame, time.deltaTime will have been updated and will increase our volume again by the next frame's time. In order to tell our coroutine to wait for the current frame to end and to start again on the next frame, we simply follow the keyword return with the keyword null. Essentially, we've turned our while loop into something more like our update function, performing the same instruction every frame. The reason why we're not using the update function is simply for better performance. Using a coroutine to perform this check and increment our volume each frame is easier for Unity to manage, and is what the developers of Unity recommend you use whenever you can. Now hopefully this makes sense so far to you, as I know this could be a little bit confusing to wrap your head around at first. So let's break it down. So on the very first frame of our game, our coroutine is called. First, it creates a new variable called timer and sets it to 0. Next, our while loop checks to see if our timer is below 1. Right now it's at 0, so it is less than 1, causing the loop to begin. So the first thing it does is increase our volume by the amount of time difference between the last frame and this one, thanks to time.delta time. Now this is still the first frame of our game, so time.delta time will give us the time between the game first starting and the first frame fully rendering. Let's say that that number is 0.1. This means that we're on frame 1 and our volume is at 0.1. Next, we increase our timer by the same amount of time that has passed, which again is 0.1. Finally, the last thing that happens in our loop is that we pause our coroutine by using yield return null and thus our loop 2. So now the coroutine can no longer continue until it resumes again, which won't happen until the next frame of our game starts. So one frame passes, and now our coroutine, and thus our loop, can resume. Again, note that this is a new frame, so whilst our coroutine is picking up from where it left off, other functions, like the update function, would run again in their entirety from start to finish. So now that our coroutine is up and running again, our loop continues. Because it left off finishing its last instruction, the condition of it is checked again. Because the timer is still less than 1, it starts again from the top. So it once again increases our volume by the amount held by time.delta time. Let's say this time that a lot of time passed since the last frame, and that time.delta time is equal to 0.8 seconds. This means that our volume would now become 0.9, and shortly after, so too is our timer increased to 0.9. Now that we're at the end of our loop again, our coroutine is once again paused. Now as you can see, this keeps happening and happening each frame, until eventually our volume and our timer reaches 1, or a value slightly higher. Once this happens and a new frame passes, our loop condition will no longer be true. Our volume will no longer increase, and thus our coroutine will finally end. Great, so our script will now fade our music in over a second. But let's say that we wanted our fade to last a little longer, or even a little less longer than a second. How might we change our script to make this happen? Well, it's quite simple really. If we want our fade to last twice or 3 times as long, we simply add half or a third of time.delta time to our volume each frame. So at the top of our script, let's create a new serialized private float variable, and we'll call it fade in time. This will represent how long in seconds our fade is going to last. I'm going to initialize mine and give it the value of 3. So my fade should last 3 seconds. Next, inside of my while loop, I'm going to do 2 things. First, instead of running the loop whilst the timer is less than 1, I'll run it so long as the timer has not yet exceeded my fade in time. So I'll quickly replace 1 with fade in time. So now the loop will continue for 3 seconds. Now my volume will still only take 1 second to turn up to full. So the next thing I'm going to do is divide time.delta time by my fade in time. So now my volume will increase by a third of the time it takes between each frame. And that's it. Now we can control how fast or slow our fade is. Another thing we may wish to change about our fade is at what volume level it should start and end at. Maybe we'd rather not fade from 0 to 1, but instead fade from 0.2 to 0.8, or perhaps 0.5 to 0.9, or maybe even we want it to fade down as it begins from say 1 to 0.7. Well, to do that, let's first create 2 more serialized private float variables. The first will be called volume start. And the second will be called volume end. Now we know that the volume ranges from 0 to 1. So let's also give these variables the range attribute with these values as the range. Great, okay, now how do we change our loop to work, even if these variables are set to values other than 0 and 1? Well, what we can do is take the difference between the two values and multiply the time we're adding to our volume by that difference. Assuming that we want the volume to increase from 0 to 1, the difference between those two numbers is 1, and therefore 1 multiplied by whatever our time each frame is won't make a difference. So it was never necessary to include. But what if we're increasing the volume from 0 to 0.5? The difference there is 0.5. So we need our volume to increase 0.5 times slower each frame so that it reaches 0.5 once our 3 seconds have passed. So first, let's declare a new float variable inside of our coroutine function and call it volume difference. Then to get the difference between our start and end values, we simply minus the start value from the end value. So we'll perform a quick calculation to get the difference. Let's write volume end minus volume start. Great, now we just multiply this number by whatever time.delta time divided by our fade in time variable is. To make sure this happens, let's add a multiplication symbol at the end and write volume difference next to it. But let's also put our first operation in brackets to ensure that time.delta time is divided by fade in time first, before we then multiply the result by the volume difference. Lastly, let's also set the volume of our audio to whatever value we want it to start at, so that we don't have to manually set it in two places in Unity, our script and the audio source. So let's write, just before we play the music, music.volume is equal to volume start. And that's everything. One final thing I'm going to do is right just before my coroutine pauses, debug.log timer. Just so that as the music fades, I can see how long it takes, making sure my script is working as I want it to. Once you've added that extra line yourself, go ahead and save your script and jump back into Unity to test it. Okay, so here I am in Unity. Now the first thing I'm going to do is adjust my new variables on my music player script. So I'm going to make the fade in time 4 seconds long and fade between 0 and 0.35. And now, just before I play the game, I'm going to scroll up the inspector tab so that I can see the volume slider on the audio source component, because as the music fades in, we should slowly see this slider increase with it. Okay, great, now I will play my game. And there we go. As my music faded in, not only did I see my debug.log function show me how long it took as the time increased, but I could also see the volume on the audio source component increase too. And of course, most importantly, I heard my music fade in gradually. So that's a very simple way to get your audio to fade in using C#. So in that lesson, we learned quite a lot. We first looked at coroutines, which we now know are special functions that don't have to be completed entirely all in one frame. We can instead tell them to pause, wait for a certain amount of time, and then tell them to resume later. We also looked at time.delta time and now know that it contains the length of time it takes each frame to pass and for our game to move onto the next frame. Great, so that was a pretty tough start to the module. As always, take some time to go back over this lesson if you need to. Feel free to try changing this script we made around if you feel confident, and feel free to check out additional resources below. Once you've done all of that, I'll see you in the next lesson.